All right, now let's do changing variables. I pretty much alluded to it in the last video. Imagine you have a function that looks like this, f of g of x, and you have g prime dx. You can carefully choose to change your variables so that you get a much simpler function to integrate. So if you look at your inner function, and if you let your inner function u equal g of x, all right, and then you have the derivative of u, okay, then what you're able to do is integrate this simpler function and evaluate it. Now the trick with this is, after you choose what your u is, and then compute du, you need to rearrange everything in terms of u. Now you may have to do some multiplying around of things. And then you'll get your general solution in terms of u. And then you're going to come back and replace your f and get it back in terms of x. So you're going to replace all of your u's in your solution with g of x. And then you're going to check your answer by taking the derivative. Let's look at this problem right here. The integral of the square root of 2x minus 1. You usually want to let u be whatever's under the radical. Let's let u equal 2x minus 1. So du is 2 dx. All right, so I'm going to take this and I'm going to solve it for dx. Dx is du divided by 2. All right, now I'm going to take u and put it in, and I'm going to substitute in dx as well. So this becomes the integral of, and I'm going to write this in exponent notation, u to the 1/2, and dx, I have to replace in this du over 2. All right, doesn't matter where that goes. So this is 1/2 the integral of u to the 1/2 du. This one I can do. So this is 1/2 u to the 3/2 divided by 3/2 plus the constant. Now, when you look at this, let me do some simplifying here. This becomes 1/3 u to the 3/2 plus c. Now, I've got to replace, everywhere I have a u, I've got to come back in and put 2x minus 1. So this is 1/3 2x minus 1 to the 3/2 plus c. Now let me do a check over here. Always check. The derivative with respect to x of 1/3 2x minus 1 to the 3/2 plus c is 1/3 times 2x minus 1 to the 1/2 times the derivative of what's inside times 2. I forgot to bring my power down, didn't I? 3/2, life happens, and then that's 0. So what am I left with? My 3's cancel, my 2's cancel. I'm left with 2x minus 1 to the 1/2, which indeed is the square root of 2x minus 1. All right. Now let's look at this one right here. This one's a little bit more complicated. Let's go on and let u be whatever is under that radical, because things under radicals get kind of ugly. So let u equal 2x minus 1. I've got this x term in here. Let me solve this for x. Maybe sometimes this works, sometimes it doesn't. Let me solve this for x. X is u plus 1 divided by 2. And du is 2 dx. So dx is du divided by 2. Let me plug all that mess in. Let's switch my pink colors here. So this becomes the integral of x, which is u plus 1 over 2, times the square root of 2x minus 1, so that's u to the 1/2. dx is du over 2. Okay, well, it's not real pretty, but it's not bad either. So this is 1/4 times the integral of, let me distribute this u to the 1/2. This is u to the 3/2 plus u to the 1/2 du. Well, that's not too bad. We can do that. So this is 1/4 u to the 5/2 divided by 5/2 plus u to the 3/2 divided by 3/2 plus c, and please don't forget your brackets there. So when I simplify this, I get, let's see, this becomes 1/10 u to the 5/2 plus 1/6 u to the 3/2 plus c. Now I'm not quite done because I want to substitute u back in. And so this is 1/10 2x minus 1 to the 5/2 plus 1/6 2x minus 1 to the 3/2 plus c. Now, am I right? You should never walk away from a test without knowing every one of your answers is right or knowing they're wrong. Let's do our check. I'm going to take the derivative with respect to x of this thing. All right, 1/10 2x minus 1 to the 5/2 plus 1/6 2x minus 1 to the 3/2 plus c. All right, let me see if I can get this right. This is 1/10 times 5/2 times 2x minus 1 to the 3/2 times 2 plus 1/6 times 3/2 times 2x minus 1 to the 1/2 times 2 plus 0. I won't write that. All right, so what have I got here? I've got a mess. That goes away. This goes to 2. So this is 1/2. Now I'm going to write this an interesting way. 2x minus 1 times the square root of 2x minus 1. All right? Plus, what have I got here? That goes away. That goes to 2. Plus 1/2 times the square root of 2x minus 1. So now I'm going to factor out 1/2 square root of 2x minus 1. And that's 2x minus 1 plus 1. Just go away. 2 goes away. And I'm left with x square root of 2x minus 1. All right. Reality is sometimes the algebra to get you back after changing variables can be worse than doing the integration. Now, let's try one with trig functions. I know you love trig functions. Oh my gosh, you got so many choices here for what u could be. But let's let u equal sine of 3x. Why? Because this is squared. So let's take the argument of the ugliest part. So let u equal sine of 3x. Then du is 3 sine, derivative sine is cosine, 3x dx. All right, so I've got the cosine 3x dx here. I need a 3, and this is kind of a little cheat here, divided by 3. So this becomes 1/3 the integral. Now this is sine squared of 3x, so this is u squared. And then I have the 3 cosine 3x dx, and that's du. See how much easier that is? All right, so this is 1/3. The integral of u squared is u cubed divided by 3 plus c. So this whole thing becomes 1/9. U is sine cubed 3x plus c. All right, let's do our check. D dx of sine cubed 3x plus c is, let's see, so this is going to be 3 sine squared 3x times the derivative of what's inside, 3 plus 0. You know what I left off? I left off my 1/9, didn't I? Kind of need it. Okay, times 3 cosine 3x, right? And I've got my 1/9 here, plus 0. 3's cancel my 9, so I'm left with cosine 3x sine squared 3x. And lo and behold, it agrees. Your turn. See if you can do these. Turn off the video when you're done. Have a great evening.